Good morning students. Today we are going to start a new chapter for class 10 chemistry, that is HCl. Now we all know HCl comes in two form. If we are talking about gaseous state, then this HCl will be known as hydrogen chloride gas, and if we are talking about the liquid state, then this will be known as hydrochloric acid. Okay, now coming to the structural part of HCl. We all know HCl is a covalent compound. Why we are saying this? Because covalent compounds are formed when there is sharing of electrons. We'll see the structure for this. For example, if we are taking hydrogen, so if hydrogen is taken, this is the nucleus for hydrogen, and we'll be drawing the valence shell here. Okay, we all know what is valence shell, the last shell in which the electrons are filled. Now see here, for hydrogen we are having only one electron because hydrogen has atomic number of 1, and if atomic number is 1, that is equal to number of electron and that is equal to number of proton. We all know this basic thing. Now coming to chlorine. Chlorine atomic number is 17, and if we are writing the electronic configuration, this becomes 2, 8, 7. Okay, 2 will be placed in K shell, 8 will be placed in L, and 7 will be placed in M. We all know what are the orbits there. Okay, now this is for hydrogen. Second one will be drawing for chlorine. Now for chlorine, what we have to understand, this is the central part of the atom, that is known as nucleus, and I am just drawing the last cell or the valence cell. In valence cell, chlorine is having 7 electrons, and if chlorine is having 7 electrons, I will be drawing here. So I will be using a different symbol, that is the dot one. Okay, so 2, 3, 4, 5, 6 and 7. Okay, now what happens? We all know that every element wants to become stable or they want to become a noble gas, and to attain the noble gas configuration, hydrogen requires 1 electron. If hydrogen is having 1 more electron, then the number of electron here will be becoming 2, and that electronic configuration will be for noble gas helium. Now coming to chlorine. Chlorine is having 7 electron in its valence shell, so it requires 1 electron to become stable or to come in octet state. Hydrogen will be coming in duplet state and chlorine will be trying to come in octet state. Okay, now in order to become stable, what they both will be doing, they will be sharing 1 electron with each other. So I will be drawing a small box in order to show that both of them are sharing 1 electron, and we all know that if sharing of electron is there, there will be a formation of covalent compound. Now another structure which we can draw is, I'll write hydrogen here. Hydrogen is having only 1 electron, so I'll be drawing here. Now chlorine, we all know it is having 7 electron in the valence shell, so I'll be drawing a 7 electron here. Okay, as we can see, 7 electrons are there. Now this is the another way of drawing the atomic structure. Now see here, what I will be doing, this hydrogen requires 1 electron, so it will be taking from the chlorine. Chlorine also wants to become stable, so it will be taking 1 electron from hydrogen. So there will be sharing of electrons. So I can draw the structure like this. For this hydrogen, 2 electrons are present, so this becomes stable. Now it's time for the chlorine to become stable, so I'll draw another circle, and this will be the combined state of chlorine and hydrogen. And we, in line diagram, if we want to write, then this becomes H bond Cl. Okay, so this is clear to you students. Now coming to the next part, that is the naming of HCl. Now there was a scientist known as Lavoisier who called HCl with another name, and that name was muriatic acid. Now this is very important for your objectives. So do remember, HCl is also known as muriatic acid. We want to know the occurrence of HCl. It is very basically found in two places. One will be when the volcanic eruption takes place, from there HCl gas is evolved. The second one is inside our stomach. Okay, so inside our stomach, what we are having? We are having HCl, and the percentage is 0.2% to 0.4%. Is it clear? Now coming to the basic manufacturing of HCl. For now we are going to study how we are converting or how we are forming HCl gas. The first lab preparation or the common method to prepare HCl is addition reaction of hydrogen with chlorine and in the presence of diffused sunlight. Diffused sunlight means a very small amount of sunlight. So what happens, this hydrogen and chlorine will be combining together and it will be forming 2 HCl. So this is the first method to prepare H2Cl2 and formation of HCl. Now see here, we are preferring diffuse sunlight. Okay, we cannot perform this experiment in daylight there. If such things happen, then what will be happening? There will be a very big explosion. So this will be a highly dangerous method to prepare HCl gas. So we don't prefer this. What we prefer? We prefer the second method. The second method for preparation of HCl is by the use of common salt, and we are using one of the strongest acid, that is H2SO4, and that also in concentrated form. Here what you have to pay attention is regarding the temperature. Now here we are providing a temperature less than 200 degrees centigrade for first case. If the temperature is less than 200 degrees centigrade, then there will be formation of sodium bisulfate plus HCl gas. Is it clear? Common salt plus H2SO4 concentrated, temperature less than 200 degrees C, will be giving you sodium bisulfate plus HCl. Second case, this is first case. Second case, the reactants are same, only the difference is when we are providing temperature greater than 200 degrees centigrade, then the reaction takes place, but there is a formation of salt, that is sodium sulfate plus HCl. Okay student, now the very important question which comes in your board exam is, why do we prefer temperature less than 200 degrees centigrade? Why we don't take temperature greater than 200 degree centigrade? Okay, in previous board exams you might have seen that this question is coming, and for your board exam this is an important question. Now see here, there are three reasons why we don't use temperature greater than 200 degrees centigrade. Now the first answer will be, or the first reason will be, if temperature is greater than 200 degrees centigrade, then there is a formation of salt sodium sulfate. This sodium sulfate will form a hard crust inside the test tube, which is not very easily removable. Okay. Second reason, if we provide heat to this, then what happens? There will be abnormal heating and there is a chance of cracking of the test tube. So your second reason will be cracking of test tube. Is it clear? Now the third point is fuel wastage. The fuel wastage is taking place because there is a crust formation, and from downward, if you are heating, the heat will not be reaching inside the test tube, and if it is not reaching, the much more heat you are providing, it is becoming useless. So there will be three reasons why we don't use temperature 200 degree Celsius. Is it clear students? Now another question, this was the first part in the lab preparation for HCl gas. Okay. Now the second question which is coming, why we use only concentrated sulfuric acid? Why we don't use some other acid? For example, why we don't use nitric acid? Okay. Now the reason behind this is, in class 9 you have studied that concentrated or sulfuric acid is an non-volatile acid and HNO3 is a volatile acid. Now what is volatile and non-volatile? Volatile acids are those acids if you provide heat then it will start evaporating, and non-volatile acids are those acids which on giving heat do not vaporizes. So here what you do, you give temperature greater than 200 degrees centigrade, and if you are using nitric acid, what will be happening? This nitric acid at this temperature will be starting evaporating, and when this evaporates, the formation of HCl do not take place. So your second question was why we don't use nitric acid. Is it clear? Now students, HCl which is formed here, this is in wet state or some of the moistures will be present here, but what we require? We require dry HCl. In order to make this dry, what we do? We react this HCl with some drying agent. Now another question which comes in your board exam is why we don't use calcium oxide, which is known as quicklime, we all know this, and why we don't use phosphorus pentaoxide P2O5 in order to dry HCl gas. Now see here, your general or the basic answer is both of them will be reacting with HCl and new product formation will be there. There will be no production or no formation of HCl. So our answer is that this two will be reacting with HCl. Now we'll be seeing one by one, we'll be seeing the reaction. What does the product form? First one is, if we are taking calcium oxide plus HCl, it forms calcium chloride plus H2O. Now you can see students, if you are using HCl, it reacts with calcium oxide and it forms calcium chloride and water. We don't use P2O5 also because P2O5 plus HCl gives HPO3 plus POCl3. Okay, so we are not coming to the balancing of this. Okay, now see here, both the cases the product are different, here also and here also. So we don't use this calcium oxide and phosphorus pentaoxide in order to draw dry HCl. Okay, now coming to the another point, that is how we will be drying this then. If this two or any drying agent we cannot use, then we have to use a specific drying agent. Now that specific drying agent will be your H2SO4 only. Now H2SO4 will be behaving as drying agent as well as dehydrating agent. Now see here, what is the difference between drying agent and dehydrating agent? Drying agent means physically water is removed from a particular compound, and dehydrating agent means chemically water is removed from the compound. Okay student, so in order to dry HCl, if your question comes, you will be telling that we are using concentrated H2SO4 in order to dry HCl. Right, now the method to collect this dry HCl gas is done by the method of upward displacement of air. Now why we do this by upward displacement of air? Because we know that HCl gas is 1.28 times heavy than air. So we use the method of upward displacement of air. Okay, and the second point in this is what it is not collected over water. Why? Because HCl gas is highly soluble in water.